The very last example in this lesson is the shot put thrower. And this is an example of the kind of word problem you're going to have for homework. And I'm going to use the calculator to help solve it, which you should probably find very helpful and to make things go much faster. So the first thing is we're going to remember all of these problems that involve throwing are going to use our vertical motion model, which I'm going to write out. And you guys, I know this by heart because you've told it to me. H equals negative 16 t squared plus vt plus s, right? And you'll remember, you have to remember what these things are as you do the problem. The s is always your initial height, right? So this is your initial height. This is your initial velocity. In other words, how much speed is going into this, right, as you're throwing. This is, if the person is throwing from, if they're short like me, they're not going to throw from much higher than 4 feet, but if you're taller, that discus is going to leave a lot higher. And then t is time in the air. And h is the final height. In other words, if there's a lot of velocity and a decent initial height, you're going to get a pretty good final velocity. All right, so that's our equation. And now let's read the problem now that we remember that. An athlete throws a shot put with an initial vertical velocity of 40 feet per second. All right, well, because we specified that here, we know v is 40 feet per second, right? Because we already talked about that. Write an equation that models the height in feet of the shot put as a function of time in seconds after it's thrown. Now, if you look at the diagram in the picture, and my goodness, I guess I'm going to have to draw a person. So, oh my goodness, I hate drawing people. All right. Here's my discus thrower. She's a girl. And when she lets go of the discus, and again, the book does a much better job than I do, it leaves her hand, and actually it leaves her hand up here, right? So I should just try to be fancy and, you know, show her hand as it arcs upward, right? But the discus leaves her hand and goes into the air. And the initial height that it leaves is at 6.5 feet. Oh, this drawing is horrendous, but you guys get the picture. So that initial height, S, is 6.5. Okay. Well, that's helpful because I can write my equation fairly easily now that I have these numbers. H equals negative 16 t squared plus 40t plus 6.5. That is the answer to part A. Part B says, use the equation to find the time that the shot put is in the air. Okay, well then we assume if they're saying that they want it to land on the ground, right? So they want to find out, right? And I'm going to show once it's thrown, right, it's going to keep going up, but it's going to follow, right, the path of a parabola and go down to the ground, okay? So we need to find the value for t if we set this equal to 0. So 0 equals negative 16t squared plus 40t plus 6.5. Well, factoring right, with a decimal is really not a ton of fun, which is why I have the graphing calculator. So I'm gonna put this right on top of my girl because I can't bear seeing her. Here's my on button, and I'm gonna enter negative, make sure you can see that, 16, and then let's see, wait, ignore, start over. What did I forget, guys? You guys know this. I need to do my y equal function. Y equal. I'm going to erase my last one. Now I'm going to enter negative 16. Here's my x value. I'm going to square it and move this over to the right. And my next is plus 40 times x. I'm putting x in for t, right? Plus 6.5. All right. I'm going to go over here and see what it looks like because I may have to adjust my window. What does it look like? It doesn't look like a whole lot. Clearly, I have to adjust my window, right? I know it's around here, so to adjust my window, I mean, it looks like I have to go pretty high on the y-axis, that I have to go a little bit high on the positive ends of the x's, but not too far down the negatives. So let's see what that looks like. Well, it looks like I don't have to go far in the negatives, so maybe I'll make that around a negative. Maybe I'll leave it at -5. But clearly I should do a little bit more on the other side, so maybe I'll make that, maybe I'll start at +5, and maybe I need to go further. I also, I'm going to go down to a minimum of y is -5. That doesn't seem so bad, but clearly I had to go a whole lot higher. So I'm going to enter 40 and then see what happens. What does that do? Okay, it's much better. But to get these values, I have to come in closer. So let me try again. And I'm going to do a -2, +4. And because I'm literally going for a couple units over, maybe between 6, I'm going to change what this is, the x scale. Instead of going by 1 units, I'm going to go by 0.1 because I'll see better that way. Here, I'm going to keep my minimum around I'll maybe bring it a little closer in, -3. I'm going to keep my max, maybe lower a little bit, see if 35 works. But I'm also going to do my y scale at 0.1. Actually, no, I'm not, because the y goes up really high. So I'm going to change that back to just 1. Not 11. 1. There we go. All right, let's see if this makes any difference. Much better, right? You can definitely see much more clearly what this looks like. So what is my question? I need to find out, right, after how many sections? Well, let's see if this trace function works. And if it doesn't, I'm going to come in even closer with my window, but let's try it. All right, my trace function is up here. I'm not going to go look over here because clearly it starts, right, at 6.5. And this is where it lands. So I want to go back to where y is 0. So I'm going to bring my trace function because the x-intercept, right, or that I want to find for that time in the air is down here. All right, so my y is -0.29, and I see I'm at 0.265 over here. Let me go back a step and see what would happen. Well, here I've already gone to 2.52, and so that's not going to work. So my best bet, I'm closest to 0 when I come here at -0.29, and so let's pretend now this y is 0. That means x is 2.6, looks like 66, or 2.65. The book gives us 2.6 seconds. Probably if I come in closer in window, maybe I'll just come in even closer by making this x scale 0.05. let's see what happens now. And let's see with my trace what happens. See if I can get in a little closer and get a better value. Oh, did I say 0.5 or 0.05? I did say 0.05. All right. Oops. My trace was way below. That's why I'm bringing it back up. All right, 2.52, negative 0.29. Now I'm not going to get any closer. So this is telling me this is 2.66. The book will tell you it's about 2.6 seconds. If you wrote 2.6 or 2.7, it would be fine. All right, this is the end of this lesson. Quick note, stuff that I wanted to tell you for homework. If you are struggling on a lesson, feel free to give me a message on Google Classroom. I will be more than happy to answer you right then and there. If I think it's a problem that other people in the class might struggle on, I will literally work it out right here, just as I'm working out these others, and I can send you the solution if I first see your honest attempt. So if you want me to work out a problem, take a picture of what you've got so far and just email it to me and say, hey, this is my start. I don't get it. And better than I don't get it, what do I do when I get to this step? Or I don't understand this part of it. And if you give me a specific question, I'll then know you've actually tried to figure it out on your own. But I am actually looking forward to working with you and being able to send you all some things that are worked out to help you. And even when we get back to the school, I'm looking forward to being able to do that more now that we found a way to do it. All right, guys, have a good end of the day. Take care and have a great weekend. Bye.